Hello, my name is Alejandro Salas, and this is my code walkthrough of my hash table projects for the data structures class. And before we begin, I would just like to briefly explain what a hash table is. A hash table is a data structure in which you store data in a pair of the data that you want to store and a key that you give that data. And unlike an array in which you have to go through all the index values, iterate through each data, um, and with a hash table, you can just enter the key in which is associated with that value and find that value immediately without having to iterate through the whole data structure. And this saves a lot of time and when you're using a large set of data. And it also saves times when you're wanting to insert a key into the hash table because you don't have to go through all of the data structure to find an available spot to put this value. And unlike an array, this data structure can change dynamically. So that was like my explanation of what a hash table is, and now I'm going to go through the program that I created that was shown in the class that illustrates this in code. So to begin, the class hash has a number, and this number is going to be the number of indexes, sorry, that will be in the hash table. And then we create a list of integers, name table, and in the public, this is going to be our functions. Basically, this is the constructor, and it's having a parameter of a number. This is the insert function, and it's going to take in. Sorry about that. This is the insert function, as I was saying, and this is going to take in the key that you want to insert, as well as the delete function and as well as the return function. These are all going to take the key that you want to delete or return in this case, and um, we'll run the function with it. And moving on to the most crucial function inside of this class, the hash function. This hash function dictates um, where the key is going to lie in regards of index values. And there's a lot of ways to get this. There's a lot of algorithms that you can implement, but the one we're implementing in this program is the modulo one, where you get the remainder of the number of indexes that you want, and but you divide that by a prime number. It's very important that you divide by a prime number because then you're going to get a lot of duplicates and a lot of chaining, and it just defeats the purpose of a hash table. Moving on, this is the display function to display our hash table. So those are the definitions over the functions. Moving on to these are the declarations, sorry. These are the definitions. Moving on to the definitions. The constructor basically takes in the integer, and as I was saying a minute ago, the number is basically going to be the number of index values that are going to be in the list. As we can see here, the list is going to be created by the number that the constructor takes in. Moving on to the insert function. The insert function is going to take in the key that the user wants to insert and put that through the hash function and push that key to the index value, which the hash function spits out. And it's very important that it will be to the back of the list. Moving on to the return function. The return function, I had to iterate through the index values and then find the key that the user wanted to find, and then go through the chaining if necessary, and then find that key and then return the index value. And then that can be seen in this line 54. Moving on to the deleting function. The deleting function takes in the key that the user wants to delete and puts it into the hash function, and I iterate through the whole table with an iterator using I, and I break if the key is equal to the pointer of that I. And then once it breaks, I find the index value in which that key lies on, and then I just delete the value. Moving on to the display. For the display, I also iterate through all of the index values, and I display all of the keys inside of those index values with auto, same as um, returning an integer. So moving on to the main function, these are just basically variables that I needed for my program. And this array, these are the values or the keys that I'm going to be inserting into the hash table. N is basically going to help me iterate, get the number of how many times I have to iterate through the insert function and get the whole values. This is the rest of the main program is basically just the UI and me showing how I inserted the functions throughout the program. And I think it's better if I just run it and show you the UI in action. Well, this is the program. It says welcome to the hash table program, and it shows you the values or the keys that are inside of the hash table, and it gives you 4 options: to display it, to find the key, to insert a key, or delete a key inside of the hash function. So let's start by displaying the hash function. And as you can see, it has 5 index values, and there's some chaining occurring because there's a lot of values when compared to the number of indexes. So it asks if you wanted to continue playing around with the hash table. You say yes, and now we're going to find this key inside of the hash table. Let's find key 23. So key 23 should return that it's inside of the index value 3. So and it says the key 23 was found on index 3. So perfect, it did what it was supposed to. Sorry about that. Moving on. Um, what else do I want to do? I want to maybe insert a key into the hash table. When we insert it, it tells you that you can't have duplicates. And then it asks you what key you want to insert. So I'll insert key 68. And as you can see, key number 68 was added to the hash table. And then we keep playing with it, and then we're going to delete a key inside of the hash table, and let's delete key 75. So when we delete key 75, it shows you your updated hash table, and we can see that key 75 has been indeed deleted. So I just clicked 1 because I just showed all the functionality that was required for this program. Overall, I had a lot of fun with the hash tables because it was way easier when compared to the data structures that we covered the past weeks, such as the binary search tree. But overall, I can really see the potential that this data structure offers for extremely large data, such as um, like storing the lottery tickets that have been handed out, and then maybe finding the winner. That there's a lot of lottery tickets, that going through all of those in an array would take a long time when compared to a hash table. Well, anyways, that's been my program. Thank you so much for your time and attention.